welcome to LeetCoder YouTube channel. If you are new to this channel, I'll highly recommend you to subscribe to my channel as I make content related to software engineering, system design, and data structures and algorithms.
Hello everyone, welcome to LeetCode YouTube channel. So today we are going to solve this LeetCode problem number 215, kth largest element in an array. So let's go through the problem statement quickly. So it says given an integer array nums and an integer k, we need to return the kth largest element in an array. Okay, note that k largest element in the sorted order, not the kth distinct element. Okay, so we need to solve it in order of n time complexity. Okay, so like this is the input array given to us. So we need to find the second largest element in this, right? So the largest seems like 6 and second largest is 5. Okay, so now let's go to the second example. So the largest element in this example is 6, second largest is 5, but we have two 5s. Okay, so second largest and third largest, then the fourth largest is 4, right? Because we have only one instance of that. So it says it needs kth largest element in the sorted order, not kth distinct element. So we need to take into account the relative frequency of an particular element, right? So if that element is occurring n number of times, then we need to count that for kth largest. That's what it means. So okay, there are various constraints given, like the length could be between 1 to 10 to the power 5, and the elements are between negative 10 to the power 4 and plus 10 to the power 4. So let's move to our whiteboard to understand this problem better. Okay, so okay, perfect. So okay, so let's say for one moment we forget that he has mentioned the constraint that we need to solve it in order of n time complexity. So what brute force approach is coming to our mind if we forget that time complexity constraint? So the brute force approach which is coming to my mind is simply sorting, I would say. Okay, so let's say we apply sorting, right? Okay, so we apply sorting, right? So what we'll do is the first step is going to be sort the input array. Okay, so let's say we are sorting it in ascending order, right? Ascending order. After that, what we can do is find the kth element, okay, from the right side, or right end. Okay, so yeah, this is our approach number 1. Okay, so let's try to visualize what is going to be the time complexity of this approach. So time complexity for a sorting algorithm like merge sort or quick sort is simply order of n log n, right? And on top of that we need space also for sorting algorithm proportional to order of n. Okay, so this is the brute force approach with which we can solve this problem. Okay, so since the time complexity is greater than n, we need to think of something better as asked in the problem statement, right? So the second approach with which we can solve this problem, which is coming to my mind, is using a kind of hash map, maybe hashing, right? So we can do hashing, right? So what we can do is we can have a simple array. So likewise, and we can store in these places, we can store the frequencies, right? So let's say the input is like this, right? 2 2 3 3 5 5 7, right? So my array would be like 0 1 2 3 4 5 6 and 7. Okay, so there are two 2's here, two 3's here, and two 5's here, and one 7 here, right? So my array would be like this. So what I'll do is I'll first iterate the input array once, and then I'll make this kind of frequency hash map, and then what I will need to do is I'll need to iterate this hash map again for finding the kth element, right? Kth element. So let me write down the steps for you. Okay, so step number 1 is make the hash map by iterating over input array on input array, and step 2 is going to be iterate the complete range of hash map and try to find the kth element. Okay, so what is going to be the time complexity of this algorithm? Let's think about that. Okay, so let's say the range which the elements can take, let's assume it's from negative k to positive k, right? So I need to at least make a hash map of size 2k, right? 2k. So let's say the input size is n only. So first I need to fill that, first I need to iterate that input array and fill this hash map. So my time complexity is order n. Then I need to iterate this hash map to find the kth element. So it is going to be order of 2k, right? So it clearly depends upon k, how it is related to n, right? So if k is far less than n, so I can take this term to be constant, right? Roughly constant, and ignore, right? Then this algorithm will become order of n. But if k is, let's say, far greater than n, the range is too wide, then my algorithm will be, let's say k is equals to, I need to approximate k, let's say k is n square, then the time complexity will become roughly order of n square, right? So clearly this approach will work only in case k is far less than n. So let's think of some more better approach than this. Okay, so approach 3. So what we can do in this approach is we can maybe use a heap data structure, right? Because whenever there is kth element asked in the problem, a light bulb in our mind should immediately light up that heap is going to be used, because heap is really handy in these kinds of problem, right? So what I can make is what is asked is kth maximum element, right? Kth maximum element is asked. So what I can do is I can maybe make a MaxHeap and do like extract max k times, and that will give me the answer, like kth maximum element, right? So let me write down the steps of this algorithm. So it is going to be first step is going to be make a max heap of size k, right? And the second step is going to be extract max k times, right? K times. So the overall time complexity is going to be order of n. For this is for making the heap, and then I need to do k times extract min. So an extract min operation is roughly log n. So the time complexity comes out to be roughly order of n plus order of k log n. Okay, so let's say how much value k can take, right? So in worst case k would be equal to n, right? It can't go further. So this algorithm will become order of n plus order of n log n. So this is the dominant term, so you can write it roughly to be order of n log n. Clearly this is greater than order of n, which is asked in the problem statement. So again we are back to the beginning, and we need to think of some better approach by which we can solve this problem. So what is a good algorithm? Let's say approach 4. What is a good algorithm in this case is actually don't make max heap. Instead, make a min heap of size k. Okay, and we need to do some kind of manipulation on that min heap. Okay, so let me demonstrate you with this example. Let's say, okay. So I think let's say we have 2 1s and 2 2s and 1 3. Okay, and I am interested in k equals to 2. So clearly the second maximum element is, the answer should be 2. Okay, so what we can do is we can make a heap of size 2. Okay, let's say I have a heap, particularly min heap with size 2. Okay, so now the next element 2 comes, right? I'm here. Okay, the 2 came. So what I need to do is I need to check whether the element that came, is it greater than the element which is at the root. If yes, then what we can do is simply remove the element at the root and add that element to our min heap. Okay, so my heap will become 1 and 2 like this. Okay, again I'll move here now to this index, and again I'll check that either 1 is less than 2 or not. Yes, it is. Then what I'll do is I'll make the heap as this. Okay, now I am at 3, position 3. Okay, so again I'll check whether it is the element at the minimum position of heap, is it less or greater. So it's less. Again I'll remove it. Okay, so my heap will become like this. Okay, so what you will notice is the element which is at the root, that is the maximum element, right? I need to perform extract min k times on this. Okay, so first time when you'll perform, you will remove 3 and you will be left only with 2, and second time you will only be left with 2. So 2 is the answer. So that's what I'm trying to say. So let me write down the steps for this algorithm. So step 1 is going to be make a min heap of size k, and after that it's just manipulation similar to perform n minus k extract min. Okay, the manipulation similar to this operation. So let me write down the time complexity. So time complexity is nothing but order of k plus order of n minus k log k. Okay, this is the time complexity. right? And space complexity is order of k only, since I'm using a heap of size k. So this approach is roughly order of n only. So this is actually asked in the problem statement. So the time complexity will be approximately order of n. So this is what they are asking in the problem statement. So no problem, let's quickly code this problem. Okay, perfect. So let's make a MinHeap. So priority queue of integer pq is equals to new priority queue. Okay, so here you need to pass collections dot reverse order, right? Otherwise it is going to be a MaxHeap. Reverse order. Collections dot reverse order. Okay, perfect. Now I'm going to iterate my array k times. Okay, for I equals to 0, I is less than k, I plus plus, priority queue dot add nums of I. Okay, now is the interesting part. For in I equals to k till I is less than nums dot length I plus plus. So I need to check now if priority queue dot peak if, let's say, nums of I is greater than priority queue dot peak, what I can do is I can remove the element at the top position. Priority queue dot I think remove is the method, and I can add this element, priority queue dot add nums of I. Okay, perfect. And then I just need a manipulation, like for int I equals to 0, I is less than k, I plus plus, and okay, let's make it k minus 1. Okay, priority queue dot remove, and then I need to return the answer as priority queue dot peak. Okay, plus plus nums of I is greater than priority queue dot peak. I need to remove the element at the top, and I need to add this element. It's fine. K minus 1 times I have extracted, and yeah, this looks fine. Let's run this code to see if we are doing everything correctly or not. Oops. For this test case, I'm getting output as 2, but my answer should be 5. PQ, new priority queue, collections dot reverse order, it's fine. I added the elements. Okay, so my priority queue would be 2, 3, perfect. 1 came, so I'm not adding that. 5 came, it will be 3, 5. Okay, then 6 came, it it'll be 5 6, then 4 came. I'm not interested in that. Okay, 5 6 case 2. I think let me remove this once. Wait a second. Output is 6 now. What is happening? The largest element is array. Okay, 3 2 1 5 6 4. I is less than k. Add 2 3 k. Then 1. So if it's greater, only then I'm going to add it. Otherwise I'm ignoring it. 2 3 1 ignore, 2 gone, 5 3, then 6 5 6 5 okay, 1. Peak, and I'm not sure why the answer is not coming. Wait a second. How the answer is 2 3 2. Wait a second. Should be 2. Okay. Is the method pop? Maybe. No, pop is not the method for sure. Method is remove, right? Let me put some test cases in this. Okay, let's put 1 2 3 only. Okay, so let's run this code. Then output is 2 and expected is 2. Okay, 3 2. Okay, then 1 game, 3 2. Okay, 2 3, 1 game, take note. There's MinHeap. Wait a second. Second maximum. Its maximum is 3. Second maximum is 2. 3 2 2 3 and 1 game. Ignored 1 2 3 3 2. Get maximum. Get maximum. I think I should do like this. Vertical dot peak. Isn't this correct? Let's write that 3 2 1 5 6 4 5 6 4. Now let's run it once. 564. Heap of size 2 only. 2, 3, 1, ignore 3, 5, 5, 6, 4, ignore 5, 6. I think this is the problematic thing. Wait a second. Let's try the second test case as well. 3, 2, 3, 1, 2, 4, 5, 5, 6. Okay. Case 4. Okay. So let's submit this. So just a minor correction I want to suggest that this is actually MinHeap, and if you place collections dot reverse order in this, it is going to be a MaxHeap. I am extremely sorry that I just forgot the difference, but I think now it's correct. So yeah, this was a tutorial I wanted to make on this problem. Again, this is an important problem, and like this is asked in the interviews a lot. So like the K based problems are generally solved by heap. So just keep the approach in your mind and you will be good to go. So once again, thanks a lot for watching this video. Do subscribe to my channel if you liked this video. Thanks a lot.
Hey guys, do check out this Instagram channel, LeetCode Community, for all the jokes and memes related to software engineering.